Okay, welcome to our podcast, Innovating the Industrial World. I'm your host, John King, and CEO of Cross, and I'm here today. We're going to talk about intro to off-highway vehicle electrification in our mobile systems integration group. And I'm sitting here with my good friends, Cole and Akash, engineers in that group, and they'll introduce themselves.
Sure. My name is Cole Koster. I'm an e-mobility engineer with the Mobile Systems Integration Group. I've been with Cross about 2 years now.
Hi, my name is Akash Hegde. I'm part of the Mobile Systems Integration Group as an e-mobility engineer, and I've been with Cross for the last year.
So why would you want to electrify something that's working great with a diesel engine right now?
Several reasons. So we're coming at it from a regulatory standpoint where you've got city governments, state governments, and federal governments that are creating incentives. Maybe they have grants available for electric vehicles that, an OEM may want to take advantage of. Other things like customer demand, where a company has green initiatives where they want to lower their carbon footprint. Maybe they want to go to an electric vehicle or hybrid vehicle.
There's also benefits in automation. Once you move to electric vehicles, you have a lot more control over your process. Internal combustion is typically a very dirty process, typically a little bit harder to control. Once you move to electric, you have much more fine-tuning over positions, over torque, and you can put in more safety if you wanted to limit your user from possibly destroying the machine. There's also benefits, like Cole was saying, with emissions. You can move your emissions to be more in a central location instead of in the cities if you want to burn fuel or you want to use energy in the cities for work functions. But overall, electrification is, we're moving in this direction mostly because of costs, regulations, and emissions.
Yeah, I think that's right. I mean, the regulatory environment for sure. You've got a lot of companies who are all about their green initiatives. You mentioned before, they can attract more investors and things like that. And you have things like noise. It's really interesting. So we've had a customer say, hey, our customers cannot operate in neighborhoods before 9 o'clock because of all the noise. And then there's a lot quieter.
And for example, in Atlanta, we just had some regulations for leaf blowers and for small engines. You can't be running leaf blowers in your city necessarily during the morning times. And, moving to electrification there would be great because now you can start operating outside of normal hours.
Interesting thing too with noise is that you get better communication. So you get increased safety as you're operating the machine.
That's a really good point. Really good point. And on the regulatory environment, a lot of people know, some people don't, that after 2025, you're not going to be able to sell or have an internal combustion engine in the state of California.
Yep. So in some states,
under 25 horsepower.
Correct.
In some states, we're seeing that, and that could be the national trend eventually. We may always still see internal combustion with hybrids and things like that. So that may be around, but we are seeing a greater trend towards, banning those internal combustion.
So that's a lot of the why. So what are the benefits that our customers get out of it and their customers get out of it? We talked a little bit about why they would want to do it, but what are the real benefits? It's not just efficiency.
So some of the major benefits of going electric is you get actually significantly higher reliability with your system. When you compare yourself to an internal combustion engine, an electric motor and electric system has significantly fewer moving parts in it. And having less moving parts means you have less lubrication, you have less wear and tear, you have less reciprocation. All those things are places where you can lose energy, where you can waste energy, or you can wear parts. And so by reducing the amount of conflict points, wear points, you're actually going to increase the total reliability of your system. And so that results in better uptime. You have less maintenance costs.
Way less maintenance.
You're not spending money on DEF or a lot of oil. And environmentally, you're not leaking oil all over the place. If you're operating in an area that might have regulations for oil leakage or fuel leakage or maybe even hydraulic oil, electric systems there could possibly allow you to operate in locations where you would not be able to operate previously.
Yep. I think the lower maintenance is a huge thing. That leads to, you're working on a diesel engine, you've got less mechanics going on there. The hydraulic system can be greatly reduced or completely eliminated. So you've got less hose breaks, less fuel leaks, all of that. And that kind of leads to just a lower total cost of ownership.
Yeah. When we're doing ROI calculations, it seems like we're always coming back to lower maintenance costs.
Precisely.
And certainly it is better in terms of efficiency. I mean, as fuel costs are rising, which you just plug it in and recharge, it's going to be more efficient. So there's an ROI there, but the ROI on maintenance is a big deal.
Maintenance and, like you said, fuel costs, rising gas costs, diesel costs, electricity seems to be kind of stabilized. And, it just leads to a total less cost.
And as our world starts moving towards pricing in the externalities of pollution and carbon emissions, we're starting to see governments put in taxes on carbon. So now Previously, there was no real cost for you to burn fuel. You could burn fuel all you want. The only cost you really had to pay for is the cost of the fuel and storing it possibly on site. Now there's going to be an additional cost in you actually burning that fuel, because now governments are accounting for the externality of that carbon and how it affects the environment. They're also accounting for diesel emissions, like extra nitrous oxides. You're going to, as you've been seeing, with diesel engines, you've been getting more and more stricter emission standards. All that goes away once you go electric.
So for sure, there's a return on investment. You
Correct.
invest in electrifying that fleet, you're going to get a return on it, sometimes longer, sometimes shorter, but it's going to happen. Cool. So this is kind of getting into y'all's strong suit. It's like, okay, let's say I'm a product manager or a design engineer, and my boss comes to me and says, hey, you need to electrify our fleet. What am I going to need? So I've been using diesel engines and hydraulic pumps and all kinds of things. What do I need to put on my list, my to-do list to come out besides talk to Cross?
So you can kind of take it as an analogy, comparing the internal combustion to electric. Your internal combustion has a fuel tank, an engine. Those are kind of the primary things we're going to take out. Everything downstream from that will kind of remain the same on the vehicle unless we're replacing the total hydraulic system. But sometimes on machines, we leave the hydraulic system the same and just change the prime mover. So we take out the fuel tank, that's replaced by a battery, which becomes your electric fuel tank.
Yep.
We take out your engine, that becomes an electric motor. Kyle?
We replace your ECU. Typically for an engine, you have a block, an engine block with your pistons and cylinders and fuel injectors. It doesn't know what it's doing until you put an ECU onto it. So we replace your ECU with something called an inverter. It does something very similar with the motor and controls the motor and tells it what speed to go, when to energize coils, and how to move exactly. Additionally, we're going to have to also add in things like a battery charger. So typically, with a fuel station, you just pull up to a fuel station, fill it up. It's already in the stored energy form of fuel. With electricity, we have to actually convert the grid energy into energy that can be stored into a battery, and there we use a battery charger to add on to that.
We can charge in several different ways.
Yeah.
Onboard charging, it's kind of like how normal EVs on the road have built-in chargers. We can also use generators to make it a hybrid. There's several different ways to charge it to kind of extend the range of the machine.
Yeah, some of which we're even getting calls right now for like remote charging, having a trailer or something to be able to go out to a vehicle and charge it remotely.
It's kind of unique for off-highway because, you've got EVs on the road that can charge up at any charging station or even at home. For off-highway, you may be in a remote area where you don't have a landline to plug into to charge. Get a generator on there, your range is totally extended. You can charge all day.
Yeah.
You're burning gas, but doing the actual work is more efficient on that electric power.
Exactly. If you have a machine, let's say you're towing a trailer and you have an electrified system on your machine, you could potentially be charging whatever machine you have with the energy coming from your vehicle. And so you could just ask yourself, why don't I just go to my job site and just run my PTO and idle my machine? Now, that is a valid way of running your machine. You've been doing that for years. However, the downside of doing that is you're using that energy in a very inefficient way. By idling your machine, by running it at that speed, that diesel engine isn't operating in its most efficient power band. So what we can do instead is we can actually charge your machines while you're driving to the job site. And while you're driving, your engine's actually in a much more efficient position. And so because of that, we can actually charge your machine and actually use less emissions than if you were just sitting there and idling in PTO.
Yep. So diesel engine, fuel tank, pumps, motors and controls, that kind of stuff. And then now we're going to replace those with an electric motor, which is actually relatively inexpensive. There's a lot of those around. Batteries, oh my gosh. Okay, so battery is where all the money is and all the technology is, and where that's growing quite a bit, but similar in terms of components.
There's also one more thing that becomes a little bit simpler, or you could say smaller, and that's the thermal management system. With a internal combustion system, since most internal combustion systems are at max 40% efficient. If you're an F1, you've got those F1 engines that are 50% efficient. But that implies that basically the majority of your energy is actually just lost in that system. Yeah. And because of that, with gasoline systems, you'll have actually fairly large cooling systems. And it's a fairly large amount of weight that actually has to be added to the machine just to keep it running. With an electric system, you have significantly higher system efficiencies. And because of that, you actually have smaller cooling systems, but you'll have some additional heating because of those batteries. And we'll get into that soon.
Yeah, that makes sense. We'll talk a little bit about, you mentioned about idling, and that's not a great way to run things. We'll talk one big advantage is around idle mitigation, the ability to actually turn off the primary engine, because, we're in the off-highway world. So we're not talking about electrifying and having a Tesla that's running around mowing lawns. It's, you're still going to be going over the road with a diesel engine, but once it starts doing the work, you're going to be able to do that electrically. So you have things like ePTOs, which is, an electric PTO rather than having to run that engine. Helps in terms of noise, helps in terms of emissions, and all kinds of stuff like that. So, being in innovating the industrial world, we spend a lot of times in factories. We've been seeing forklifts that are electric for ages, and I know they're 48 volts. And you hear headlines about the Porsche Taycan is 800 volts. So what's this whole, low voltage, high voltage thing? What are the advantages of going high voltage? What are the sort of pros and cons of staying low, staying high?
So this all goes back to the power that's being consumed. So you've got on-highway vehicles consume a lot of power, similar to off-highway where you've got excavators, street sweepers, all of that are consuming large power. As your power goes up, Ohm's law is an electrical engineering principle that we use that says increasing voltage decreases current. So as you increase your power, if you keep your voltage the same, your current starts to spike. And that makes your cable diameter larger, et cetera, larger components basically. If we increase our voltage, we can bring that current down and make the components smaller. And as we have smaller components, less copper content, we get higher efficiencies in the vehicle as well.
Yeah, because we've even run into applications where the cable size was ginormous and heavy.
So probably a low system voltage.
Yeah.
As we increase that voltage, we can get that diameter cable a lot smaller.
So typically for low system voltage, you'll see with these forklifts, they have typically batteries that are supposed to be readily swappable or readily changeable. And the reason why they're going lower voltage there is for personal safety. It doesn't require as much certification, safety training. And so you can just take someone who's been driving forklifts for years and put them in an electric one. They're allowed to charge it and maintain that vehicle without too much extra training. You compare that to a high voltage system where I believe OSHA says that anything over 50 volts is technically high voltage. Automotive, we really specifically will say more of like 60 volts, 72 volts. Anything above that is more high voltage. But the main reason why, another big reason for high voltage is faster charging. As Cole was saying, as you increase your power, you have two things you can play with here, and that's your voltage and your current. And power equals your current times your resistance, your current squared times resistance. The resistance of your system is basically the same. You have the same wires, you've got the same components. But if you want to increase the power, if you increase your current, you're going to be generating a lot more heat. And so when you're wasted heat. And so when you're trying to charge, if you're putting a lot of heat into your battery, that can cause battery degradation. And that's typically not what you're going to want to do when charging. You do not want to degrade your battery while you're charging. And so what we typically will do is we'll go to higher voltages. And since we're running lower currents, we actually heat up the battery less during charging. And that allows us to actually charge at higher powers and get you back on the road quicker.
It's less battery heat, but it's all components. You got less motor heat, less inverter heat. The thermal management system is loaded less. So you've just got an overall lower heat on the system.
But so on the lower end of what we're doing work-wise, in terms of power, we're in the world that we play in is like where you look at 48 volts, I think 96 volts. I think and we have a 300 volt system that we work on as well. Correct?
Yes. So typically we like to say that anything that's under 30 kilowatt hours, we like to try to keep under like around 48 volts low voltage.
Yeah, which equates to like 24 horse. Yeah. Really, that's kind of our playing zone. Anything around 24 horse, that's our 48 volt threshold.
Yeah.
If we get above that horsepower or power rating, that's when we start to move up in voltage to handle the larger currents.
Yes. So is it linear? So if we're going from 48 volts is 24, 96 is around 50, 96 volt is equivalent to around a 50 horsepower motor?
Yeah, and we take it kind of case by case. Some machines don't need a 96 volt battery. Maybe they need larger capacity. So we've got a large capacity 300 volt battery. Yeah. That may be a good application.
And sometimes customers want the ability to certify their vehicles for maintenance without having to go through extra training. And in that case, they may specify, I want a 72 volt system, or I might want a lower voltage system, not a 300 volt system.
Call it touch safe. Makes so under 100 volt, they want touch safe so they can work on it without worrying about being electrocuted.
Yeah, that's a big deal in terms of our design and all that kind of jazz. So if you're doing a big amount of work, like we mentioned, the street sweepers, that kind of jazz, you're doing a lot's going on there, you're going to want a higher voltage thing. Correct. If you also are thinking about, I need a lot longer. When you're buying a car, you think about range. How far am I going to drive? But we think about work cycle.
Exactly.
How often, how long am I going to use it and how often? So longer, bigger work cycle, you're going to want to go to a 300 volt system.
Precisely.
Yep. Higher voltage, that definitely helps the efficiency, which helps battery range. But also you can increase capacity on the battery itself. So if you want to stay at 48 volt, you would just increase capacity of the battery, make it a larger battery essentially.
Yeah, and so those forklift batteries I was talking about before, those were lead acid AGM batteries. That's just old school. We're all lithium now.
Sure.
And everything in terms of our 48, 96, and 300 volt are all lithium options, which that's what you hear the much about. One of my kind of last questions we get into this is we've run into applications, as you know, where people had big long work cycles, and there were, as they would say, there's not, you couldn't tow enough batteries in a tractor trailer truck to do what I need to do in a 12-hour day. So, kind of a question I have is this sort of a race to hydrogen? One of the things that we talked about is in that application is can't do it with lithium. You may be able to do it with a fuel cell eventually. Is this lithium just a step to get to hydrogen, or are there applications for lithium where that's going to stay and applications later on for hydrogen?
I'm under the impression that for our national security, that hydrogen should be the way to move forward. Currently, one of the big problems with lithium ion currently is the supply chain to actually get the material. And right now, China actually does control the majority of that supply. And because of that, I believe that's one of the reasons why Japan also does not, it's not been moving really fast to doing electrified vehicles. You see Toyota and Honda, they're kind of lagging behind Korea right now when it comes to electric vehicles. And I believe that's because they do not have the supply chain to actually support the production of batteries long term. And that's why you see Toyota and Honda both pushing heavily on hydrogen. Actually,
I was in the Bay Area just 2 weeks ago, and I was sending you guys a picture of a hydrogen vehicle.
Yes, and you see with hydrogen, you have quicker turnaround times because it's very much like a middle ground between battery electric vehicles and gasoline. In the form, gasoline with fossil fuels, that energy has been stored over millions of years of the earth, compressing these organic beings down into oil. And so that energy is effectively free to us because, all we have to do is drill it and pull it out of the ground. There was a lot of time and power spent actually compressing it down into that fuel, but for us, it's free. Hydrogen, we have to actually spend some energy in order to store energy. Mm-hmm. That's because of electrolysis. Electrolysis is generally a pretty energy expensive process. And because of that, you'll see right now, majority of hydrogen production is done through cracking natural gas. And while it is a more efficient process, it doesn't take us away from, obviously, from fossil fuels. But there's an interesting thing that you can do with hydrogen, and that's using it as a battery. So right now, as we move more and more towards this renewable grid that we're building, with more solar, with more nuclear, with wind, things like solar and wind, they don't match demand of the grid very closely. Mm-hmm. And because of that, you need a way to store that energy when it's being produced. So typically, you'll use most of your energy during the evening and night. That's when your lights are on. That's when your air conditioning might be running. You're trying to go to bed. You're actually home then. But most of the energy for solar is produced during the day. So you need to find a way to actually store that energy. And right now we're doing that through pumped hydro storage and through batteries. There's another thing that we might be able to do in the future, which is using hydrogen as storage. So while energy is cheap because of abundant solar, you can actually run electrolysis and start storing that energy in the form of hydrogen. Then you can use that hydrogen to actually power your vehicles. You can use that hydrogen to put back into fuel cells to put it back into the grid. You can use that hydrogen in a thermal power plant and use that to actually generate energy that way. The big thing about hydrogen is that it can be used actually in a lot of internal combustion engines. Toyota right now is working actually on internal combustion with hydrogen. Mm-hmm. And because of that, it makes it a lot easier to transition to hydrogen with bigger machines and weight sensitive machines like rockets and airplanes. Airplanes can't be carrying around batteries. It's too heavy. There are plenty of companies that are trying their best at that, but I'm under the impression that hydrogen is going to have to be the future for airplanes and air travel, and especially for rockets. And so by setting up that supply chain and moving that way slowly, I think that we'll have a more secure future for energy.
Yeah, it makes sense.
And I also think that we'll have a cleaner future because we're not mining rare earth metals like cobalt.
Mm-hmm.
We're not
itself.
Yeah, exactly.
But now that I'm that product manager that we were talking about before, and it's on my to-do list to get this done next week, I can come to you guys and you have a solution for me for 48 volt, 96 volt, 300 volt.
So lithium ion is readily available currently.
Yeah.
And
we have solar charging, we have all the inverters and all that kind of jazz you need.
Yep.
Motors, batteries, the whole thing. I can come to you guys and say, hey, help me do this, and you can say, here.
We've got the full system.
Cool.
The entire electric powertrain. I think going back to hydrogen, one of the biggest reasons why we're not there yet is the infrastructure.
Correct.
A hydrogen fueling station, they do exist in California, but as far as the rest of the United States, they're just not there.
Yeah, we've run into that. Maybe one per city, which is interesting. I mean, it's in the city, but you got one where you got
because they're expensive.
Yeah, similar to electric vehicles, you didn't have many charging points previously.
Yeah,
and it only takes one industry mover to actually push this forward and people to adopt it for that to actually start taking off.
Cool. Well, sounds great. This has been really super helpful. So, again, I know where to come if I want to electrify my fleet.
Come to us. We'll help you out.
That's awesome. Thanks.